So today I'm gonna explain about what I have done as my lead backend role and what I have done for the Matcron backend projects and also what I have contributed to the Matcron. So first of all, I'm gonna talk about the CI/CD pipeline, which is continuous integration, continuous development pipeline. So first of all, I'm gonna talk about the Docker Compose. As you can see, this is the Docker Compose file, and it uses the Docker file, where the Docker file is uh, a script that tells the machine that what should be copied and what sort of architecture that is built. What's so special about this architecture that is mentioned here is because that each of the machine have different CPU architecture, like for example AMD and ARM. So like if I want to host it on Ubuntu or maybe a Raspberry Pi, which is a Pi OS system, so that it requires a ARM architecture system. So I will need to build it in that way to be compatible to it. And another reason that I also mentioned that in the Docker Compose, I have Docker SQL Server, but this is a image is using the MySQL images. The reason I picked this database is because that Raspberry Pi can only be used is not only but is compatible with MySQL. But previously we used SQL Server, and the reason we migrate and change to MySQL, one of the reason is that SQL Server is not compatible with Raspberry Pi. So it's not a big issue to us because we, thanks to SOS service oriented architecture, that we learn how to create services that does not require big changes to the database, and it just requires us to change the database access and DB context, and it's easy. So because of the application DB context, it makes us use the ORM, or maybe we call it entity framework. It's in a easier way, so that we can just directly call the matrices and access the data. So moving on to the CI/CD, continue on. As you can see that every time there's a put, merge, and push, because we set the rules only that when it's merged to development branch, it only generate the build for Docker images. As you can see, this is one of the example of Dan getting the build for ARM architecture Docker, and this is all the process to it. And then after doing done for the images, where does it go? It of course goes to the Docker Hub of their repository. As you can see, there is 3 tags: AMD, ARM, and the latest one. This is all the images that will be used for my deployment and hosting on Raspberry Pi. So I'm gonna show you that once I have taken down the server, how do I upload it? So as you can see, this here, currently this is all the container that I used. So as you can see, this is the backend, and the tag is ARM, and it was hosted on the port 8082 of the current device of my Raspberry Pi. And once anybody using a request to port 8082, it will redirect it into the 8080 of the container, which is our server backend. So now it's just a simple command, and I can show you the Docker Compose file. This is all the Docker Compose file that I use to put on the Raspberry Pi server. So to host it, so it's easy as just a single code of line. and it will generate and create all the server, and the container is created now. So other than that, you can see that there's Nginx proxy manager that I use for hosting. So how it works is I just need to go proxy Matcron online, which I use to host the thing. And this is the password and the email address. So as you can see, there is total of around 5 proxy hosts that I use to redirect to our own server. So here, as you can see, this is AI, which is used for host for the AI chatbot services, the API of our backend. This is the proxy which is redirect us to this Nginx proxy manager. This is the router which is used for configuring our to redirect to our machine, which is the Raspberry Pi. Now moving on, I'm gonna show you that this is our backend that proving that the backend is working. And so I'm not gonna show every features because due to the time limit. So what I'm gonna show you now is that proving that the 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 backend is actually working. So to access the mattress, we use the Postman for development and testing out if the API is working. So for example, this is our URL, as you can see, and we're trying to pinpoint the request to our Raspberry Pi. And this is the JSON format, which a sample of the front end that how it will receive. As you can see, there's the ID, the type, location, status, days to rotate, organization. Then this is a sample of the mattress that can be created. So the reason of it failed is because that the mattress type is not found. So it proven that here that it does do all the validations and verifications for it. So I'm gonna bring up the database that I show here. So as you can see, at the left column, this is all the table. As you can see, all the table is here. Group, log mattress, mattresses, mattress group. So moving on to the mattress type, this is all the variable, their attributes, name, width, length, and then we go into their data. So what we do is we copy the data and we go back to the mattress type and we paste the mattress ID and we create it with a mattress. As you can see, the mattress is successfully created and this is their ID. So now what we do is we go to the single mattress ID. What we do is we place our ID inside. And this is we successfully retrieve the mattress. So to prove that it was inside, what we do is we query the data from mattress where the UID is this one. So this is the data that we newly created.